All right, you guys, hush. Class has started. Shh, quiet down. Okay. So today, we are going to be starting chapter 6. No, chapter 6 is the beginning of volume 2. So for volume 2, I'm going to give you guys the option. This is where you see if you're looking at a volume 1 or volume 2 book, it says it right here. For volume 2, if you feel like, man, I would really just rather keep this book with me all the time, I'm going to let you keep the whole book. Okay? Now, the problem with that is if you lose it, I can't replace it. Okay, so before, if you lost your binder or your pages, it wasn't a big deal because all of the other chapters were still in the closet, right? But now if you lose it, you lose the whole year, right? So the other thing is that I know your backpacks are already very full, and this is kind of heavy. So I don't know if you want to carry this around every day. You have to bring this to class with you every day, okay? So the hole punchers are over here. We got this one plugged in, and then we have the other ones in the bookshelf. So if you want to just rip out chapter 6 like we have been doing all year in hole punch, you can. These are the page numbers. If you want to keep the book, that's fine too, but get a marker and put your name on the pages, okay? Because you will get it confused with somebody else, and then or you'll leave it somewhere and you won't know if it's yours, and someone else will be like, well, I lost my book, I'm taking that book, you know, and things do happen. So put your name on it if you decide to keep it. As far as classwork goes, I have some notes for you, and then we're going to do 2 graphs, okay? So when you go into the closet, there's a big box of books on a chair, and there's another box of books on the bookshelf. So why don't you guys start this side of the room, go ahead and get a book. You decide whether you want to rip out or keep it. And then when they're out of the closet, you guys go and you guys go.
So we're done with this book, volume 1. Under the sun, we had 2 mornings. Let me tell you, I was having a great weekend. I was really good. Here,
You know what I did on Saturday? I lost my book time.
Yeah.
They got the tapes because I just keep buying. Their faces were purified. All right, Janelle. Are you keeping the book or did you tear out pages? Avery, are you keeping the book or did you tear out pages? Natalie, are you keeping the book? You're gonna keep the book? Dave, not here. Louis. Daniela. Carson. Brandy. Okay. If you're keeping your book, did you write your name on it?
I did.
Kylie.
I'm keeping it.
Good choice.
Jared. Dennis.
I never liked it.
They are your notes. These are your notes. Okay? You're not on your phone. Put your phones away. Kevin.
I actually threw my phone.
Alicia. Miley. keeping them up? Like every class. Alexis.
I, in fact, ripped the pages out.
Dude. You better. Funny. That was corny. Stop.
I tore out. Is that recording? Are you okay? No, no, no.
Keeping the book?
Oh my god.
You guys fix the names on it?
That's pure fire.
Or you can just
They were.
Oh, job. You know how long I got like that? Yeah, absolutely. I just hold so long. My hair used to be so long. You already know it used to be long. Do you know how to go here? Like, did you see it? It was like right there. And then it's like, now it's like right here. That's why.
Alright guys, here's our new function. This is called the exponential function. Last chapter we talked about exponents a lot, but the exponents were numbers. This whole chapter, the exponent is the variable x. So that's what makes an exponential function, is that your variable is actually up high in the exponent spot. So when we graph, we're plugging into the exponent. Okay? Some definitions about an exponential function. Well, the base is always positive, and it's never 1. If you put a 1 in here, 1 to any power just stays 1. It's a flat line. It's a constant function, not exponential. Okay? Another kind of rule here is that a can't be 0. If you multiply everything by 0, then this whole equation would just be 0, which is not exponential. So there's some rules about what the numbers in the a spot and the b spot can be. Now, if the number in the a spot is greater than 1, and the number in the b spot is also greater than 1, that is called exponential growth. The graph will start low, and it will grow to be very high. If the value in the a spot is greater than 0, and the value in the b spot, so the base, b for base, if that's between 0 and 1, so what kind of numbers are between 0 and 1? Fractions, like 3 over 4, or 2 over 5, or decimals, like 0.8, 0.7, 0.3. If it's anything like a fraction or a decimal between 0 and 1, then your graph will look like decay. It'll be something that's decreasing. Okay? So we're looking at growth and decay, and it's pretty common on like an SAT. They're just going to give you an equation and ask, something like growth or decay or matching a graph, and it's all about understanding the base creates the growth and decay. So for classwork today, we're going to graph one growth by hand, and we're going to graph one decay by hand. All right, so if you have graph paper, this is a nice time to use it if you have your own. I'm not giving it out today. If you don't, that's all right. Do this on notebook paper. This is required classwork. I will be walking around tomorrow and giving you credit for doing it. So this is required. draw this for me?
I have my own outfit at home though. I'll hold my pencil at home.
Okay, so for our growth, our base will be 3. And for our decay, our base will be 1/3. We'll be using the same table to graph both of these. Let me know if you need me to go back or anything. Here's what we're doing for the next, at least 10 minutes. We're going to be filling these 2 tables out. We're using the same X values. This is nice. Last chapter, there were so many questions about where did you get those X values in that table? How did you come up with this? This one's nicer. It's the same X values for all of our graphs in this section. So same old plain old -2 through 2. So it's cool. This time we're actually plugging in to an exponent. And with graphing, you're allowed to do a fraction or a decimal. Whoa. So I'm not going to undo this whole thing right now. I just want to get one done. We're going to do it. Take your earbud out. What's 3 to a -2? 3 to the -2 power. We know 3 squared through √2 is 9. What happens if the exponent's negative? Yeah, you got to put it under 1. So I'm now going to make this 1/3 squared. So it's 1/9. Okay? That's kind of a really important part of this graph is understanding when you put a negative in, you don't get a negative out, you get a fraction. So negative numbers don't create negative y's, they create fractions. And did it pop out 0.1 or did it pop out? Yeah. Yes, you can, and you can even do 1 divided by 9 and get a decimal. When you make graphs, you're allowed to use decimals.
Is that 3 to the second supposed to be negative? Or is that actually positive because you put the 1 over it?
Right. When you put the 1 over it, it becomes positive. And then that makes it a fraction, which is a really tiny number. So you go ahead and finish your table. You don't need me to do the exponents. Y'all know how to do that.
I have another pencil.
No, I have a 0.7. It's close to 0.9. I don't like 0.7.
Wait, I actually might have a plus. You're off it. Let's verify. What is it? Oh, is it 0.7? Let me look. All of these are going to be 0.7.
Is that possible?
Yeah, someone here said it. Bro, nobody uses 0.5 unless you freaking do it.
If you have makeup work, like you missed the test last week, you can do it at 5 anytime. And I'm available after school every day but Tuesday. Not here Tuesday after school.
You have another 0.5 pencil. Yeah, I'm saying nobody uses it. Well, only he uses 0.5 doesn't have another one.
Because I'm a girl, whatever.
So what is it? This
I use 0.5 and I'm using 0.7.
No, 0.9 is the perfect way. Guys, look at how great my handwriting is. The 0.9. Okay, do you want to see what my handwriting is at 0.7?
Thank you. Look, I got a 0.5.
Good for you. That's perfectly.
I don't care.
Okay, let me write it down.
Alright, so now I'll do 3 -1. That's 1/3. Do you guys remember what 3 to the 0 power is? It's 1. Kind of crazy. We're plugging in negatives and we're plugging in zeros, but we're not getting negative numbers out. And we're not getting 0 out. Interest, please put your phone away in your backpack. Keep it away in your backpack. Jaden, you got your buzzer? Take it out. Oh, yeah. Alright, 3 to the first. 3. 3 squared, 9. So here's our ordered pairs. -2, 1/9. -1, 1/3. 0, 1. 1, 3. 2, 9. So, the really important characteristic about this graph is that there'll be some type of floor or ceiling to it. Yes. Yeah, good question.
Hey, Alexis, this is safe space.
No, it's sorry. I need to do better, guys.
We need to ask questions.
Somebody slap me. I need to stop being mean to people. No, I said you need to slap me.
Okay, like 5 to the third. 5 times 5 times 5 is 125. And then 5 times 5 is 25. And then 5 to the first is 5. And then somehow this is 1. No, I'm about to. I'm in the middle of it. And now this is 1/25. All right. So the pattern as exponents get higher, how do I turn 5 into 25, right? 5 times 5 is 25, and then 25 times 5 is 125, and 125 times 5 would give me the next one. I don't know what it is. But if you look how they get smaller, 125 divided by 5 is 25. What's 25 divided by 5? 5. Now, what's 5 divided by 5? 1. So when exponents get smaller, think about it like division. 5 divided by 5 actually results in 1. 1 divided by 5 is 1/5. 1/5 divided by 5 is 1/25. So we mostly think about exponents as multiplication, but if you think about it reversed, you're dividing. And that's why anything to the 0 power is 1, because it's that number divided by itself, which is a 1. I'm glad you asked and listened, because a lot of people just go through life angry. They don't get it. How do I graph 1/9? Well, what happened here with these tables is that you're always going to have this fraction with the negative. So here's 1/9. It's not right on the x-axis. It's just above, because that's like 0.1 or something. And then 1/3, I try to show a little bit higher, but I try not to make my 1/3 look quite like 1/2, right? So here's 1/9, 1/3, and then finally 1, and then 2, and then 9. So right here, even if I made my table go to -3, it would not be a negative number. It would be a fraction. And -4 would also be a fraction. I'm not ever going to get negatives out. So it's really important that my graph doesn't go negative. If this thing swoops negative, then you're not graphing it correctly. You have to have a little floor here at 0. So for that reason, we usually put a dashed line in there to show I'm not going to go below here. This dashed line is called an asymptote. An asymptote is a line that a graph will approach at its ends, but never cross. at the end. Yes. But somebody asked, Alicia, you already went? So, yeah, asymptotes can move up and down, like, based on the equation, but all exponential equations do have this, like, floor. So, for example, let's say let's say I added a big plus 8 to the end of this graph. Like we've been shifting functions all year, this big plus 8 would shift the whole thing up 8 units. So then I would do a dashed line up 8 units. It's still the same shape and everything, but the asymptote is up 8. So there's always a floor with these graphs, a place where it really starts to get flat. It's not perfectly flat. It's just getting really close to that number. So hope that makes sense. You gotta have this dashed line. Another thing I'm just gonna tell you, and you don't have to write, is that I could put a -1 in front, and that would flip it over. So a -1 in front, like this can be reflected. It would look like that. Like it's a perfect flip. It would be close to 0 and then just head straight down. So there's lots of transformations with these. Today we're just doing this base graph. All right, we haven't talked about end behavior since like November, but it was discussed with this graph quite a bit. So end behavior is where we did the arrows and the infinity signs. So for this graph, on the left side, the y is approaching 0, doesn't cross it. That's why we have an asymptote. And on the right side, the y value is going up to infinity. So end behavior is talked about because of this like flat line that's created because of the exponent. A lot of information there. Instead of just reading everything and then having you guys write it down, hoping you remember it. When you're ready, go ahead and do the 1/3 and see how different you creating it yourself is. Best case scenario. Yeah, y equals 1/3 x power.
It says a line. A graph approaching at its end. So why don't you ask? That's a question.
Does it represent the dash line or does it represent, like, I'm really confused.
Yeah, it's the dash. The asymptote is the dash.
Okay.
Lois, please put a smile on my face. He needs to realize that it's a blessing God woke him up today.
You watch the Super Bowl?
Huh? Oh.
You watch the Super Bowl?
I don't think he watches.
You don't watch football? You watch soccer? No? You watch what? Basketball? What about you?
Baseball?
Basketball?
You watch football?
I play basketball, I'm gonna watch basketball.
I don't watch basketball. I play, oh, wait. Oh, forget.
We had a big debate about basketball.
How about what?
Basketball is
Basketball.
They're not making as much as the,
Yeah, but they are making money. They're making professional money.
What people make is cool.
it's because not as many people even watch women's basketball as men's basketball.
Yeah, but that's what somebody said, but then I looked up the numbers and actually people are on the
Really? Someone said that they should lower the rim to 9 feet because a lot of like one of the things that draws people to watch basketball is like the dunking. So like
I fully believe they should make the basketball court larger.
Really?
God, it's already pretty hard to run down there.
I'm
getting tired already.
As the athletes are like getting taller, it's like the proportions are off. Like,
I think basketball.
I think we should expand the men's basketball.
Besides baseball.
Let's make the men's one
Do you
taller.
think weightlifting?
And swimming in the men's.
There's
I
most
do
fun
think-
sport to
I
watch
think
in
maybe
the
we should make women's soccer field shorter.
Yeah,
It'd be
that's
much
so
more
true.
entertaining.
Yeah, that's kind of
Mhm.
true.
Just gonna keep the pace.
It is pretty good.
It is pretty.
I got real tired running down that shit.
Okay,
That's it.
all right, so let's look at 1/3 now. When the base is 1/3, so not a lot has changed in my equation. Instead of 3, I have 1/3. It's gonna create a decay graph. So how do I do 1/3 to the -2? Like Luke said, you can't just put it in your calculator, get a decimal out, get a number out. That's totally fine. Here's the way your calculator's working. It's doing 1 to the -2 over 3 to the -2. And so this part goes down and this part goes up. So that's actually 3 squared, which is 9. So it's weird with a base fraction and a negative exponent, your number actually gets bigger. So I put that -2 in and I get a full regular 9 out. You might question your calculator when you see that, but that is right. So I'll wait until you guys finish this one. And then I'll tell you domain and range. You can see the two graphs side by side.
What's your say? You're hungry? Are you just tired? This bubble that you don't run a lap or two.
That's what I had to stop doing for caffeine in the morning. I just my hand's already shaking. I haven't drank any caffeine. You know, like I can't sing.
Alright, so I'm seeing the same Y values, but they kind of switch. So this time the -2 gives the big 9, and the -1 gives the 3. And so this time it starts up high and then it slides down low. I think I can do better. Alright, so a lot of times people call growth like a ramp, and then they call decay like a slide. The decay will swoosh down. Each time x gets larger, y is getting divided by 3. So it's 1/3 is big. So the sentiment is there. Think about dividing by 3 instead of multiplying by 3. And that's why we're so whooshing down. So same asymptote, but the end behaviors are flipped. So this time on the negative, where x is approaching negative on the left side, y is going to infinity. And then when x is going to the positive right side, the y value is going to 0. So these graphs are kind of notorious for questions about domain and range, end behavior, and asymptotes. So I'll just value, we're looking at x could be anything from negative infinity to infinity, but your y values are always going to be greater than 0 because even when you plug in negative x's, you still get out positive numbers. All right, guys. So in your assignment, it looks like a lot, but the first 7 is like using a calculator and plugging in, and then I assigned 2 graphs. Does this seem like too much?
Yeah.
We can shorten. You want to go to odds? So you're at 2, 4, 6.
Yeah.
If you guys want to go to odds, you may. If you are no, because I don't want to encourage you. Jiggy, but did you do the classwork
Yes, I did not. Cannot put you down.
Yeah. It does go down, but it doesn't go below the axis. This right here. This one. This has a negative sign in front. This is a reflected. This is the growth flipped or reflected.
I love it, guys. Great way to start off.
Not trying to get me by the way. Page 5. As long as your fraction's actually less than 1. Like if your fraction was like 10 over 7, then